Hello, everyone. Welcome. We're here to talk about the magic of custom InSpec resources. I have the pleasure of introducing Sam Levnick from Google to my left. I'm Stuart Patterson from Chef. It's good to know magic still draws a crowd, so happy about that. I thought I'd start a little bit by talking about InSpec itself. The two main sort of parallel use cases for InSpec are infrastructure testing, where you would test the kind of literal parameters of your stuff that's out there, maybe in the cloud. So if you had 100 VMs in your production setup, you would want those 100 VMs to be up at all times, and they would be named VMs. For your continuous compliance checks, however, these are things like policies. So it could be to enforce particular taggings across all your real estate, or it could be to disable SSH ingress across all of your VMs. So those are two examples of those just up there. So let's talk a little bit about how those two use cases are satisfied by Cloud Resource Packs. So here is a typical control. On line 7, you'll see that we instantiate a resource, in this case the Google Compute region. We give it a project and a name, and then we test a particular thing. We say it should be up. That's nice human-readable syntax, but it doesn't come for free. So what we have to do behind the scenes to make that work is write a resource class. So I don't expect you to read all of this. I just want you to get a feel for the effort behind the scenes to get that human-readable syntax up front. So most cloud resources actually boil down to a couple of things. So it's a cloud API call that's made, results are usually unpacked, and then we have parameters and methods on a resource class that are accessed in a human-readable way from the control. So if we zoom in on that method we were just talking about, it should be up actually maps to a resource method up, and it's the InSpec DSL that does that linkage for us. So that's one resource. But what about resource packs in general? So you take a collection of lots of resources like that, and it's called a resource pack. But how do you get started with that? So if you wanted tomorrow to pick up and run with InSpec on GCP, what do you do? Well, there's not an app for that, but there's a command for that. It's InSpec init profile. You give it the platform name, and you give your profile a name, and then it generates all sorts of stuff. There's a libraries directory for your custom libraries that may help you do things that are tailored to your setup. There's an example control that I'll show you in a second. And then there's an InSpec YAML file, which is where the dependency on the resource pack is explicitly declared. So let's look at what the sample control looks like. The top one should be familiar to you. We looked at it earlier. It was instantiating the region and looking at a property on that region. So that first one looks more like it aligns with the infrastructure testing use case we were talking about. The second one, though, is more aligned to the continuous compliance use case. So on line 22, you'll see that we actually use a plural resource in InSpec to draw out all regions that are present, and then we instantiate a test for each individual region and do a test. In this case, again, it should be up. So if we run that, what you see is we didn't sort of ask for each of the regions to be specified by name, but they're all there. So if Google add a region, you know that that's also going to be tested. So for the region case, it's less important, but if you had a similar patterned control that was, again, SSH ingress is denied for all VMs, then it's quite a powerful thing that can run in the background continuously and make sure you're compliant. So about a year ago, almost this time last year, we started InSpec GCP. And it was a matter of handcrafting about 65 of those InSpec Cloud resources. So instead of the full spectrum of what GCP has to offer, we zeroed in on the resources that were required for CIS certification, and then eventually managed to get CIS certified. What's slightly obscured on the bottom there is we're also certified for Azure and AWS now at this point, which is good. To make all of that work on an ongoing basis, though, we need continuous validation of these resource packs. So we've got a CI setup where we stand everything up, test it, and then tear it down again on an ongoing basis. And we use industry standard tools, so Terraform, to stand up the resources. They only exist for the length of time it takes InSpec to test them, and then we notify of success, failure, and other things. And as a shout out to ChefConf London, we are going to do a talk on that topic for those that are interested. So where are we with InSpec GCP and Magic modules? Well, from our point of view, it's really allowed us to rapidly expand the resource coverage of InSpec GCP. But the second point is, for us, it insulates us from API changes. Now, that's important because CIS benchmarks also depend on, let's say, beta APIs, and these are subject to change. So without our processes behind the scenes, we wouldn't be able to adapt and cope with those. So we've actually started the migration of the existing resources over to Magic modules. The POC is done, so we're confident we can do that. And our aim is to then achieve button press generation of the resource pack. And I'll hand over to Sam now, who's going to tell you how that works in practice.
Cool. So when I started working on the InSpec GCP repo about 5 or 6 months ago, the basic functionality had been covered by Stuart. So all the compliance, or the resources that are needed for the compliance testing, that was all written by hand. And so my goal was to expand this coverage so that you can write not just tests against resources that are covered or that were covered at the time, but that you can write them against any resource that exists within the GCP environment. So I was on a team that has this tool called Magic Modules. It's a code generation tool. It takes, or I'll get into that later, but the goal for Magic Modules is to create a comprehensive, consistent, and cohesive resource pack. So we want to cover all of the GCP products, and we want all these resources to work and look fairly similar. And then we want these to be updated all the time, kind of change as the API changes. So before we get into how Magic Modules works, I'm going to talk a little bit about what a cloud InSpec resource actually has to do. So this is a little bit different than what I would say like a operating system resource has to do, because for a cloud resource, what we're doing is we're interacting with an API, generally making a GET request. So that's step one, retrieve this resource by issuing a GET request to a specific URL. Step two, we're going to parse whatever JSON result comes back. Maybe we need to do a little error handling in case of unauth or anything like that. And then we need to surface the results from that JSON result to the user for testing. And as we do this, we need to also have tests, integration tests like Stuart was talking about earlier, so that we can make sure that these resources still work as they're testing APIs that could potentially change. We need docs so that users actually know how to use these resources, and we need examples to include in those docs. So I'm going to go through each of these steps and kind of talk through how we generate each part of them. And it turns out writing InSpec resources can be kind of tedious. I don't particularly like writing the same code a whole bunch of times. So at the time that I started working on this, I think Stuart said they had covered 65 resources. And to get to full coverage of the GCP API, we need to add a lot more, and it's a lot of repeated code. So we also need to keep all of this stuff up to date, which is a hassle. You need to somehow know that something has changed in the API, so you need to be watching that all the time, and all of these pieces need to be updated. Just to give you a picture of what exactly, or how many files are involved in creating a new resource. So I'm gonna step through kind of examples of each type of file that's needed to be added for a single resource. So this is the singular resource for region. We've got an integration test that runs on the back end to make sure that this works. Got docs. And then we got the plural resource. This allows you to query multiple regions. And we got integration tests for that, and docs for that. So what if we didn't write all these? The general goal of Magic Modules is to, or how it works is taking a description of the API. Here's a simple description of an API response. So this is what comes back from the API for a given region. This is just each of the types, each of the fields that comes back in that response and the type of that field. So what we're going to do is we're going to take that description of a region resource and turn it into the actual InSpec resource that a user can use. And we're going to turn it into the docs and the plural resource and the plural docs and tests along the way. So before we get into that, we need to break down what exactly needs to be in that API description. So this is just a snippet of the description for a region, but the important parts are the URL to query to get this resource, and then the list of fields that's going to come back, and the types of each of those fields. So you can start seeing down on the bottom, we've got this list of properties, one of them's name, and then we've got some user-facing descriptions. So the first step to creating one of these InSpec resources is to be able to retrieve that resource from the API. In our case, that's going to be a simple we're just issuing a GET request to this API. We need to qualify, so we're combining that product URL you can see on the bottom with the resource base URL. So the full thing is just going to be those stuck together, and then we're going to replace the project in curly brackets and the name with the project and name of the region that you're looking for. And then we're just going to issue a GET request there and check for a couple error responses, but then give that JSON body back. So this part is pretty easy. It's generally the same for all of the GCP API because it's pretty standard. And yeah, we'll get a JSON response. So parsing the JSON response is a little bit trickier. I've got a little diagram here. It's just follow the arrows. So we're going from the description of the result body that's coming back. That's on the left. That's the JSON. We're sending that through this parse method. And I kind of wanted, so the part in the middle, or the top right, is actually the ERB that's compiled to generate the parse method on the bottom. So Magic Modules is written in Ruby. It's a bunch of ERB files, templates that get compiled with the description of the API to create the actual InSpec resource that gets used. You can kind of follow, if you take a particular field from the JSON on the left, and you can follow it through, you can say, for the ID, which is a string, you can see the way that we actually parse that ID in the parse method. Because it's a string and it's Ruby, you can just assign it. It's not actually a big deal. That's true for most basic types, strings, numbers, etc. Where it gets a little bit more interesting is the nested objects and arrays of objects. So in this case, you can see the region quotas. It's an array of objects. So we're passing that to this other, the region quotas array class, which also gets auto-generated. And that has a very similar parse method to this. So it basically just recurses down through the JSON types and figures out how to parse everything. The next step that we have to do is write documentation and tests. This is actually, or documentation is pretty easy because we've got these descriptions of what a field actually means within that description of the API. And so we're just combining that with the field name and surfacing that to the user. So what I want to do now is take you through the process of actually adding a new resource to InSpec GCP using Magic Modules. So what I'm going to do is go through the example of region backend service, which is a GCP resource. It allows you to configure internal backend services that you can use within your project. The actual use case for it is not particularly important for this. I just want to kind of show you what I have to do to create a new resource via Magic Modules. So this is the reason I chose region backend services, because it's the most recent one I've done. I did it about a week ago. And this is the code that I actually wrote to generate this InSpec resource. This is test code. It's all being compiled. But this turns into the integration test that runs to make sure that this resource actually works. This file also gets compiled to be examples within documentation. So if you look at examples within the documentation for these resources, it's the same code that's being run in the integration tests, so that we know that that the examples that we have in the docs are always working. This is a little bit overly complex. You can see the general, on line 4, it's where it's describing the actual backend service, and then it's a lot of kind of strangely compiled stuff, but it's not too bad to write. So just keep track of this. We've got about 13 lines of code here. So the next thing I had to do was I wrote a plural test template. This is the test for the plural region backend services. Again, same basic thing, 9 lines of code, and it's just this test that's going to go both to the integration test and to the docs. So I think we're up to 22 lines so far. Next, so we need to actually be able to provision a region backend service so that we can test it during the integration test. So this is the Terraform that does that. 30 more lines, so we're up to 52. And then we need resource-specific configs. So these variables are used back here to provision the region backend service. They also get filled into the integration test template so that we're actually testing fields on the region backend service. It just pulls it into both places. So another 11 lines. I forgot how to count, but I think that's about 65. And that's it. This is all the code that I had to write. Because I was lucky enough that another team member had already written the API description, I didn't have to do any of that, of writing that big block of YAML. But that's part of the benefits of using Magic Modules, is that I get to use the API descriptions that other team members have written down for similar projects, such as the Terraform Google provider. So some of those resources are generated via Magic Modules as well, and I get to benefit from the efforts of other people on my team. So I think that's pretty good, writing about 50 or 60 lines of code. Generally, most of it was actually the Terraform template, and then getting the full 6 files of plural, singular, and docs and tests out of that. It's pretty good. It makes my life a lot easier. I don't have to maintain all of these things. If anything changes within the API description, just go update it, and it automatically fixes it in all the places it's needed. So as far as progress with Magic Modules, we've generated 70 resources so far, and that includes a singular, a plural, and a markdown doc for each. So I think 35 GCP resources turns into 70 InSpec resources. This is pretty awesome. I've done this in just a couple months, and this has really helped us flesh out the coverage of the GCP API and made it really easy for a user to test their infrastructure. So another thing that Magic Modules gives us is a single place to make edits to all of the generated resources. So I had a demo yesterday, pretty early on in the day, where I showed off something that I had made with Magic Modules, where I have a GCP environment and want to write InSpec controls based on that environment. And so it would actually go through and for every cloud resource that's up there, so every compute VM, every firewall rule, every SQL database, it would actually turn each one of those into an InSpec control. So this is mostly useful for infrastructure testing rather than compliance testing. And this is actually one of these sample generated resources. It just goes through and lists all of the properties, fields on that resource and writes it down in an InSpec control so that you can run this later and make sure that the specific resource hasn't changed. So this can be used for drift detection, but what I really want to talk about is how Magic Modules made that easy to write, because having a single place where I could add that kind of functionality, I had to add new methods, new functionality onto each one of the InSpec resources, as well as some stuff onto plural resources, so that I could write like an individual resource to a file, so that it knew how to write itself as this control. And writing that over 70 different files is going to be a nightmare. It's going to be a real hassle. So what I was able to do is kind of genericize that, put it in one place, and then be able to fan it out to every generated resource, which is pretty awesome. So yeah, that's Magic Modules and how it works. And if you're interested in any of this stuff, it's all available on GitHub. You can just search Magic Modules. All the templates are there, all of the API descriptions, all that stuff. Yeah, awesome. Any questions?
Yeah, all right. You mentioned that double the coverage. There were 70 handwritten ones before. Are you going to go back and replace those so that they're all?
I'll take this one, I guess.
Yeah.
Yeah, so the question is, are we going to replace the existing resources? Yes, absolutely. So what's interesting about the existing resources is they'll have a lot more of the, let's say, tailored methods that I was showing, which are specific more to CIS and other sort of, let's say, standards and controls. So yeah, we're committed to go back and do that work to migrate them all over, because we ultimately want that button press generation of the whole thing.
You said Magic Modules on GitHub, so are you going to use it for, say, other providers, so we have coverage across everything?
That's a really good question. I would very much like to do that, yeah. I don't know if management will shoot me for this, but yeah, absolutely, I would like to do that, and yeah, it's something that we're talking about. Sorry, the question was, are we going to use Magic Modules to generate other providers' InSpec resource packs? So for us, that would be very useful for, obviously, the big three clouds, so AWS and Azure.
Cool.
Any others? No? Going once?